For more videos, visit forthesakeofeducation.com. Alright guys, let's do this problem. Determine the normal force, shear force, and moment at point C. So the first thing we can see is that it has a pin, so it has a vertical and a horizontal force, so it's not really convenient to use this side, but as you can see, V only has a reaction going up. Let's call it Vy. The first thing we're going to do is find Vy. To find Vy, we're going to do the sum of the moments about A. Let's assume going clockwise is positive. We know that the sum of the moments at A is equal to 0. So the moment created by this 10K force is 10K times 1.5. 1.5 is the distance between A and 10K, plus the moment created by this 15K force is 15K times 4.5, this distance all the way here, and the Vy is going the opposite way, it will be turning it counterclockwise, so it's negative, times the 6 meters, which is the distance between A and the force. And all of this is equal to 0. So when you solve for Vy, so you pass this and this to the other side and you divide by 6 and you get that Vy is equal to 13.75 kilonewtons. Now that we have Vy, we can use the method of sections to find the normal force, shear force, and moment at C. So we need to cut. We're going to cut this right here. And we're going to get this section where this right here is C. And this is the pin at B. And it has Vy, which we found to be at 13.75 kilonewtons. And we have a force of 15 kilonewtons at 1.5. This is 1.5 meters and this is 1.5 meters. So you know that at C you got a normal force and C, shear force Vc, and a moment at C. And this is what we're trying to find. So first let's find Vc. Find Vc. So to find Vc, we know that the sum of the forces in the y direction is equal to 0. We're assuming this is the y and this is the x. So Vc is going up, plus 13.75 of Vy minus the 15K, this is K, of the force going down, and all of that is equal to 0. So when you solve for Vc, it is equal to 1.25 kilonewtons. Let's find the moment. Find the moment. Let's assume going clockwise is positive. The moments, the sum of the moments at C is equal to 0. I always like to assume the same I assumed here. I assume that MC is going clockwise, so I assume the same thing here. So the moment created by this 15K force, 15K times 1.5, because it's the distance from C right here, this distance is 1.5, minus 13.75, which is Vy, times 3, which is the distance from NC to Vy, plus the moment, because we assume the moment is going clockwise. And all of that is equal to 0. So when you solve for the moment, you get that the moment is equal to 18.75 kilonewton meters, and it's positive, so it's going clockwise. And last but not least, we're going to find the normal. And this is very easy to find because you know that the sum of the forces in the x direction is equal to 0. There's no other force going in the x direction, so NC is equal to 0. Final answer for the moment, final answer for the shear moment, for shear force, and final answer for the moment a point C and the normal.
Please comment below if you want me to do any problems and I'll be happy to help. Thank you.